Now I'm going to show you how to automatic drill this hole here. To make it simplified, I will show you only diameter 10 hole with different length and with closed hole, and I will show you how Cimatron will handle this automatically. To create, to start, just create the drill procedure, because you can use 3x or 5 axis. I'm going to use 5 axis. Part surface, you no need to select one hole by hole. You just select everything. That's all. And then apply groups. Group also, you just select everything to apply the group. And when you select the grouping, you need, for the true hole, you need to see there's an arrow. This arrow show you where the drill will come in, right? So I don't like this direction, so I just click on the arrowhead, and it will change to these directions, right? And okay. So after you group, the next step is to apply the template or apply the circles, right? But before that, we need to make sure that this path here, you must you this one to browse to your template folder, right? So if you use Cimatron, you should have one standard template folder for your company that have all the machine template of your company. So then click OK. Then just click OK. It will automatic program the part and then calculate. That's all. This is how easy to program in Cimatron by using AutoDrill. Next, I'm going to show you how actually I machine this hole automatically, and what cutter is involved. So I will use a machine simulator. Let's load the machine simulator. And this is a big machines, and the reason I put the part at this corner because the longest gun drill that we are using is around 1 meter. That is why. So let me hide this. And okay. For the first tool that we are using is actually the sander drill. And then the next tool will be a diameter 10, 50 mm drill. So for this long hole here, it will not cut to the end, of course, but it will cut only 30 mm depth as a pilot hole for the gun drill. 30 mm. For this hole is less than 50 mm, and this is 50 mm drill, so it will drill until to the end. And this one also a pilot hole for the gun drill pilot. And this hole here to the end, because it's less than 50 mm. So how about the two more hole? Two more hole. The whole length is actually longer than 50 mm. That's why cannot use this drill. But shorter than 100. So Cimatron will automatically select 100 drill to do the drilling for the hole to the end. And then next will be gun drill. It will change to oh no, sorry. Next is actually a chamfering. Yes, we have a false alarm here because the CAD model don't have chamfer, and we are using a chamfering to cut the chamfer. Basically, it overcut the part, by 1 mm. So that's normal. So it's false alarm. Then okay, let's continue. So this all is chamfering too. So let me speed up. Doing chamfering. After chamfering, all the hole now we have around 1 mm chamfer. After chamfering, next two will be a gun drill, diameter 10, and the length is 400. This is the cutter, right? So you start move the gun drill to the approach positions, right? And at this stage, you can slow down the feed rate. Slow down the feed rates to enter the pilot hole. Down to pilot hole depth here. Then when you're at the end of pilot hole, next is to machine 5 mm guide. We call it guide, and you can machine this guide with, for example, 50% of free rate. So I'm going to zoom it out here. This all you can set in Cimatron. Yeah? So 5 mm guide and drill until here with 50% free rate. After this 5 mm, next is to drill to the full depth because there's no cross hole here. So you will drill to the full depth with 100% of the feed rate. Right. So after going down to the full depth, we can ask the tool to retract. For the next, it will retract 1 mm. And the tool will stay there for maybe 2 seconds, 3 seconds. This one all you can set. One of the possible reasons is so that we give some time for the chip to go out. Yeah. So after drill, we retract the tool back to the pilot hole depth, and again back to the clear. Okay, for the next one is the same. For this one, a bit different. Again, first we will approach, then move to the pilot hole with slow down feed rate. After that, drill 5 mm with 50% feed rate. Okay, after the 5 mm, we will drill with 100% feed rate up to 5 mm before the cross hole. Yeah, up to 5 mm before the cross hole. Because here we have a cross hole. Why we need to do that? So that we can slow down the feed rate at the cross hole. Slow down the feed rate at the cross hole, and this will not. It will help to protect the tool, and also your hole will not get tilted. So it will slow down until 5 mm after the cross hole. This 5 mm value you can set inside Cimatron gun drill setting, of course, right? So after 5 mm, after the cross hole, next is to drill at 100% feed rate. Again, there's a cross hole here, so 100% until 5 mm before the cross hole. Then change the feed rate to 50% and continue drilling until 5 mm after the cross hole. Right? And change to 100% feed rate, drill until 5 mm before the tool break tool. Okay, 5 mm before the tool break tool. Then you will change the feed rate, slow down again, maybe 50%. So this will help to protect the drill edge to avoid it to chip off easily. This is one of the reasons. So slow down and break through. Right. So I've set the setting to the machine's 1 mm extra. So after breakthrough, then the drill will pause at that positions for some times. Again, one of the possible reasons is for the chip to flow out, and then after that it will back to the pilot dead, right, and also back to the clear. Okay. So the next hole is the same. There's no cross hole, right? So you can say by using the 400 mm is not enough. So the system will add another cutter. The next cutter will use a 800 mm gun drill. This is a 800 mm gun drill. 800 mm gun drill, but the diameter is 9.95. Right. So now we have a pilot hole from the previous gun drill, right? 400 mm. So first you approach and go down to the pilot hole. Okay. Pilot hole 4 mm. And then machining 5 mm guide and continue the drill with 100% feed rate until 5 mm before the cross hole until here, right? Then you change the feed rate to 50% and then through the hole until 5 mm after the hole, and then to the end with full depth. Right. Same also for this hole. And this is the 1 meter gun drill, the last one. Okay. The 1 meter gun drill is the same. So first, of course, now you already have 800 mm pilot, so it will go down straight to the 800 mm pilot, do the guide drill, and then down to the full depth, and after that retract and then back. Right? Let me rewind. Right? So as you can see, the drilling process is quite complex, right? If you do it manually, I think at least you need how long? 5 minutes, 10 minutes, 20 minutes? I'm not sure. But you have just seen how I program this. It's only a few seconds. Okay? By using the template. And the most important thing is when I do the programming for the hole, I know nothing about the tool involved. I know nothing about how should I program the gun drill. Right? All the setting is from the machining template that your company set, and that setting is proven setting, and it can be used by all, but no need to know by all. Now I'm going to show you how to build a template to automatic drill the hole, the diameter 10 hole. For this type of hole, we have two types. One is through hole, one is blind hole. Because of that, we need to create two kind of template. First, I will show you how to create one with the blind hole. So for now, I will use the 3-axis to program. So I will change the UCS to G55 and click on procedure and go to drill, and I will select the 3-axis. You can use 3-axis drill to program a template, no problem. Yeah. Again, saves. You select everything. The system will recognize all the holes only at these directions. And then we make a group, do a grouping, and we are not going to apply any template, but I'm going to show you how to do it manually. So I'm going to work on this sequence here, this group. Just double click, and immediately we'll enter this page. Do you see this label here? This is the label. ST is the stop top. SB is the stop bottom. Okay. That's why when you doing AutoDrill, you need to create stop. Okay. The first cutter that I'm going to use to drill this diameter 10 hole will be a center drill. So I'm going to add. I have already some drill prepared here, center drill, diameter 3. So I'm going to select this. And after select, it will automatically drop into this place. And you can set your settings. Let me, my screen is a bit small, it's okay. So this is the retract, and this is the bottom, right? Retract, we start from stock top. Of course, we must use stock top. And also for the bottom also, I'm going to set this drill to use bottom stock top also, but with a bottom delta -3. Minus 3 or 5 is up to you, right? You can see the 2 now go down for the bottom, go down 5 mm from the stop. Right, and the reference point is cutter tape, and I'm going to use a spot drill. Spot drill is G81. And the feed rate RPM, I'm not going to talk about this. You should know, you can get it from your cutter supply. Yeah. So that is the first drill I set for this hole. That is the center drill. Next, after we have the center drill, I'm going to add the next two. The next two will be my drill diameter 10 drill with a length of 50. I'm going to select this. Okay, so let's cancel this one. The starting from ST is okay. The ending this time I'm going to set as BT. BT means that, let me zoom. That is the whole bottom. BT. There's BT, and of course the bottom delta. For this I'm going to put 0. Machine until bottom. Okay. And I'm going to use maybe a high-speed pack. This should be G73 to do the machining. And Period RPM set by yourself as your supplier. And what next? Next, I'm going to show you how to set conditions. Okay. To set the conditions first, because why we need to set condition? Because the maximum depth of this drill only 50 mm. Okay. But if we have a hole longer than this, we want Cimatron not to select this tool to cut. So how to set the conditions? First, we need to apply something, do something here. Here's the parameters. The A range, the A height. I'm going to set this template, okay, to work in a range of, A is the hole depth, from 0 to 900, okay? 0 to 900, no, because we, at the end, we have a gun drill of length 1 meter, so I can put 1 meter, okay? I can tell Cimatron that, okay, this template can work with a hole from 0 to 1 meter length, diameter 10. So diameter, we fix it. Here, we fix it. And we need to add a parameters, a variables, for us to do some settings. And this one, I'm going to use the A height. I'm going to click here, double click, and key A HGT, A height. Right? And A height also, I can set a range from 0 to 1000. Okay, that's a variable for the height of the hole. So no more, you can go to the helps. Here I'm going to show you the online help. Right? X is either A or B or C, the whole feature. So if you want the top diameter, you just put underscore top. In this case, I want the height, so I put A underscore HGT, and you have other options as well. You can also use the smaller than, greater than, equal, or this is not equal, I think. Yeah, not equal. And this and not, yeah, and parenthesis. I will show you how to use this. Okay, now here I will set the conditions. My condition is, for this cutter, I will use A underscore HGT. I will use it if the height smaller than 50. I will say 51. Of course, you can type like this. Okay. So this means that if Cimatron detected a hole with the height is less than 51, why I put 51? Sometimes, yeah, the CAD model, the hole is 50, but you have plus minus some tolerance, something like that, to overcome the problem. I think, yeah, we can put 51. Yeah. So if less than 51, if we use this cutter to drill. There's another way to set this. in this case, I will link this 51 to the cutter diameter variables. So yes, I can put a bracket, and then inside I can say that is 5D of the cutter. So TLDI is the variables, and this gives us 50, right? So maybe we want the plus one, so 51, and also we need to put a bracket like that. So this formula also gives us 51. So if I key in this formula, if I change the cutter or somehow the cutter chain or what, or the length will follow. Yeah. That's 50 mm drill. Next, I'm going to add the next longer drill. Going to insert, and I'm going to choose the length 100. Let's move this down. You can move down, right? For this top, ST is okay. For the bottom, of course, is the BT, same as previous, right? And this one, yeah, I can use high back, same settings. And maybe for this, yeah, just now I forgot on the coolant. I should change the coolant. Of course, for the center drill, flat, and for this one, I use flat. But for this long drill, 100 mm drill, I will use the true coolant. Yeah, true coolant. Same setting as previous, but this one, I will make a copy, put here. I'm gonna apply the conditions, right? So less than, previously is less than. Now I'm going to say greater than and equal. So I'm telling Cimatron, if my hole height is greater than or equal to 51, 5D plus 1, yeah, use this cutter, right? But that is not enough. I need to set that condition again. Some more. That's N. Okay. I tell Cimatron that, okay, you can use this 100 mm if the height larger than 51 and smaller than 100. So here I can put maybe 101, yeah? So 10D. This is a 10D drill. Plus 1. Right? So this condition tells Cimatron that, hey, if there's a hole, the height is bigger than 51 and less than 101, use this drill to drill. Next, I'm going to add the pilot drill. I'm going to use the diameter 50 mm. Use that drill as the pilot drill for all the holes depth more than 101. So I'm going to add. I'm going to choose 50, the length of 50. Use this one as my pilot drill. Let's move it down. And okay, how to set this? For the pilot, and we can start from here. ST is okay. And for the end, BT, no, we're going to start from ST also. ST, okay. We are going to do pilot here. So start at ST and ST. For the pilot, we click here, the bottom delta, to key in. What is the pilot depth? Your choice. 3D, 30 mm or 20 mm. Let's say now I set maybe 20 mm minus 20. Right? So I can key in the value directly, minus 20. But this is a bad practice, because if you change the tool, the value will not change, right? So again, I'll suggest you all to use formula, put -1 time 2 time TLDI. The TLDI is a 2 diameter. So this will give us 20. Again, -1 time bracket 2 time TLDI and enter. Right? It will give us the same value, but what is different? The difference is we are using the formula. Right? If you click, you can see the formula. Right? So if you change the tool, this value will change also. So this is a pilot. I'm going to machine 20 mm. And again, I will use this pilot tool to machine a pilot hole only if the hole is longer than 101. Okay, because if smaller than 101, it has been machined by either length 50 or length 100. So I'm going to make a copy of this. Up here. So this one, I'm going to use it if it is bigger or equal to 101 20. Right? So this is how I set it for the pilot. So after the pilot drill, the next is to get the gun drill. The shortest gun drill that I have for diameter 10 will be length of 440 D. And I will select this gun drill. And for this gun drill, we're not going to start from the ST because there's no more stop on top, so we need to change to DP. Right? We need to refer to the whole top, the DP. And to the BT. Okay? To the BT. And there's no offset 0. And because this is gun drill, we cannot use spot drill. Cimatron have a gun drill function here. Yeah, my name's Gun, by the way, and this is my drill. Gun drill. And next, I'm going to set the setting for this gun drill. Just click Access. After click Access, then you have a dialog, and automatically Cimatron knows this is a blind hole, right? So you have an option here to set first the pilot depth, right? In this case, we are using the 50 mm drill to drill a 20, so we put 20 here, right? To avoid, for safety, if you want, you can put 20, that's okay. And after move the drill into the pilot, and then to start drilling, so we can specify the guide. This is called guide, right? So we can say, okay, I want to drill 5 mm as my guide, and the guide, I will change the feed rate if possible, right? So this is here. Here's the settings. For the positioning, we want to do some settings. Maybe, because gun drill normally is very long, and you don't want to, for positioning, don't want to rotate too high. Like, let's say, the RPM don't set too high. No, you can say I don't want to rotate also if you want, either off or clockwise, but set the RPM lower to positioning, right? And pilot, yeah, this is setting for the pilot when the tool enter the pilot. The RPM, you can set my, I don't know, maybe let's say my 100% is my RPM, so let's say I'll put 50% of it, it will be 500. And the feed rate, I will set, okay, maybe I'll slow down, right? Slow down 50%. And coolant, maybe I'll flat, I will use flat instead of true coolant. Maybe this one I will choose 300. Yeah, see, you can change. It's up to you. Then at the guide side, because I want to slow down the feed rate, because this is where is the first cut, first cut. So maybe I put how about 30% of feed rate. Since 30% of feed rate, this one will maybe reduce 300 maybe, right? And you can have like use a flat if you want. Yeah, because it's just cutting 5 mm flat. If you can change to true also if you want. Maybe I'll put flat, just enter. And then this settings for gun drill. So my 100% RPM I set 1000. Okay. For the actual RPM and the feed rate, please refer to your gun drill supplier. I'm not an expert on that. Okay, I don't make gun drill, although my name's Gun. Yeah. So let's assume the feed rate that this gun drill can use 500. I'm gonna set 500. Right. So this 500 and the coolant for the gun drilling, that is this section here. Yeah. Is true coolant. I'm going to use true coolant from this point on it. And also at the middle there might be some closed hole that already machines, right? So I set 5 mm so that when the drill comes before this closed hole 5 mm, we can slow down. Here in the section, we can slow down the feed rate, right? This will protect the drill and also make sure your hole will not get tilted or bend. So 5 mm before and 5 mm after is standard, 50%. So after the intersection, if there's have, okay. And then you will drill to the bottom. After bottom, here you can set a backup distance to move the drill back after reach the bottom. Up to you. I can put 1, and you can set after drill bottom, it will back, move the tool back. Okay. And it will drill. Later, I'll show you where to set the drill. Retract. This is the setting for the retract. For the retract, you can choose to reduce the RPM if you want. You can retract by feet. Okay. And you can set your feet. What's a percentage? And the coolant, true, yes, the true coolant still on. I'm not going to change it. Yeah. So basically, this is how you set the gun drill. Quite straightforward, right? And then after done, you just save it. You just save it, right? And inside this gun drill procedure, you still have options, right? To set the drill for spindle change, right? If you change RPM, the machine needs some time to get to that RPM. So it's good to set the dwell time, the waiting time, right? Maybe I'll set 3 seconds here. And also you have the option also dwell at the whole bottom, okay? Sometimes you might want to do this, right? to drill so that I know the chip can transfer out from the hole, right? Maybe. So this one will put maybe 3 seconds. It's up to you. Drill at the bottom. Yeah. That's it for this gun drill settings, right? And for this gun drill, I'm going to use it only if there's a if again conditions here. Maybe copy. Only if it is bigger than 10, bigger or equal to 10, 101, and smaller than 401, 401, right? If there's a hole, the depth is bigger or equal to 101 and less than 401, it will use this drill to drill. So next, how about if the hole, the height is bigger than 400, right? So if the bigger than 400, then we will use this gun drill as a pilot drill. So I'm going to select this and insert. Same, I'm going to insert a same kata, 400. Okay, move this down. But this one for DP, okay, but for the depth, I will start from DP. And also, I'm going to set this one -1 time this 400, right? This is 40D time TLDI. Right, so it's 400. From 400, so it will machine to the maximum. Okay, and this hole will become our pilot drill, pilot hole for the another gun drill with a length of 800. Right. So the setting, I'm going to use the same setting that we have, same setting, yeah. How about the conditions? The condition will be, I'll make a copy of this, copy, and I'll put here. When to use this drill, the condition is if it is bigger or equal to, if bigger or equal to 400, right? This will be 40. So if it's equal to 4, bigger or equal to 401, the height, use this gun drill as a pilot drill. Now let's add the gun drill, the next gun drill. The next gun drill will be the length of 800, but the diameter is smaller, 9.95. For the second stage gun drill, the diameter has to be smaller. And 800 lengths, okay. I'm going to choose this. Let's move it down. And for this, the top DP is okay. For the bottom, let's reset this back to 0. For the bottom, I will set to BT. Okay, so we set to BT. And how about the settings? Yeah, we need to change some setting now. Okay. This is what we need to change, right? So previously we have make a pilot hole by gun drill 400 mm, so I'll put maybe 399, right? The rest is the same, so save, right? So then we'll put conditions. Let's make a copy. Condition is if the hole is bigger or equal to 41, okay, use this drill, and also smaller than 800, 801, use this drill to drill. Next, how about the hole that is bigger than 800, 801, right? And for that hole, we need to use this 800 gun drill to do the piloting also, right? So add again the 800 gun drill for 800, right? Let's move this down. And for this, yeah, we cannot use BT, we have to use DP, but we set the bottom delta, and it's 1 time bracket. So we have done 800, right? So it's 801, so 80 times TLDI. So this will be the pilot value, delta, 80 diameter. Yep, okay, it's good for me. Okay, so I'm gonna machine do this step. The settings is the same, no need to change the gun drill settings, and but the formula is different. push into the maximum. The formula will be let's copy this, make a copy. It's the same as formula, but 800 here, 80. Okay, so this will tell Cimatron that if there's a hole bigger than 800, use this one as the pilot drill, right? Next, let's add another drill. It will be the longest drill. It will be this one, 9.9, but the length is 1 meter. Okay, the length is 1 meter. And okay. 1 meter, okay. Okay, so this is 1 meter, and right, so again we'll reset this 0, change the bottom BT, right? So I need to change the settings. So previous the pilot drill we have done until -796. So go to change the pilot settings. It will be 796. It will be 795 maybe. Yeah. Okay. And then stop on DP to the BT. We've changed the pilot setting, right? That's now, yes. And next we need to set the formula. So the formula will be same as this formula. Let's make a copy, put here. And in this case, I would say if bigger than, if the hole is bigger than 80 plus 1, right? If the hole is bigger than 80 plus 1 and smaller than 1000 plus 1, and use this drill. Right. That will be our settings for the last drill. I think I missed out something. Yeah, chamfer. After center drill, 50, 100. Then after pilot, yeah, we need to add a center drill somewhere here. So let's select, no, chamfer drill. So I'm going to add here the chamfer. chamfer tool. Yeah, let me 16. I will add this chamfer tool here just before the 400. And for this chamfer, we it is a chamfering, so we start from I'm going to use a spot drill, of course. Start from DP to DP to also DP. Let's go to look at this. Yeah, DP, then we need to move down the reference to chamfer diameter, right? And chamfer diameter, I will put maybe the whole diameter. And yep, we're going to use this variable, the underscore top. So let's add some variables here, one more. Add. And this will be the A underscore TOP, top. And this will set a range of fix, right? Fix, A top. So I can set here chamfer diameter to be A underscore top plus, I don't know, 2. There will be 12, right? So that's our chamfer. Yeah, from the CAD model, it's up to the designer, right? So most designer, they don't create a chamfer in their 3D plate, right? That's okay, you know? That's okay. We still can set for the chamfer at the campsite. And there will be the chamfer tool. And this chamfer tool will be for all, yeah, after the 50mm pilot. No, I don't think the chamfer we can set for all. We also set the conditions. I will copy the deepest hole. I'll set here, right? So the maximum is I will use back, no change. For the minimum side, it must be bigger than, I think, because it's 0 or 1mm or 2mm, you cannot do this chamfer, right? We need to have some minimum depth, right? Maybe I'll say, how about 1-2 diameter? Yeah, I can put, let's say 1D of the taper diameter. That is 16. Diameter 16. Yeah, it's okay. This is just for example. So this chamfer will take action if the hole is bigger or smaller than diameter 17, and if the hole height is less than 1,101. Okay, that's the range. That's set. Yeah, that's it for all the drill. After done, you just click OK and OK, and you should have something is done. So there's some problem, you need to check. Right, what is the problem? After checking, and I found out why. Okay, I'm going to show you why. So if you see, after you calculate the AutoDrill, if you see this message, then something is wrong. To know exactly what is wrong, you can always right click and look at the log. And here we tell you the clear problem. The clear somehow it become minus 200. Why? Okay. So let's go to check, because there's no logic. This is zeros here, so it cannot be minus 200. Sometimes you might have problem like this. So it's 200. So it's clear, right? 200. To solve this problem, we can always use the variables like max z. That is the maximum selected surface z. Okay, but you can key in the mean. There's another one, mean, also min. So it will give me a 0 value. So with this highest point, I'll plus another 100. Okay. So if my path change, this will change. So this will solve the problems. And I also found out another problems regarding my formula. This one. For this, the last gun drill here, I cannot use this formula because the gun drill length is 1,000, but the diameter is 9.95. So the final value of this is not 1,000. So in that case, I can always key in 1,000 here. Or I can always check what's the this is short, so-called short names. If you don't see it, right click short. If you don't see it, just right click and click show short names. Then you show short names. Yeah, then you can see the variable. So you can always find the cutting line, right? The cutting line is CTLN. So I can always write CTLN here, CTLN. Okay, and it will solve this problem. Yeah, CTLN. And how about this one? So we have problem with this one also, but this in this case, this one no choice. We have to change this one to 1,000. Set as according to the cutter variables. So do we need to use this? Yeah, let's put 1,000 here. No choice. Right, done. then OK and calculate, and yes. So now I have some two part. Let's look at from this side. You know what? Let's look at the side. It's better. Yeah. Right. Let's look at like this. Much more better. Right. So we'll have a first one, the standard drill. This is what we do. Second one is a pilot drill, 50 mm, and then chamfering tool, and then 400 gun drill, right? And then 800 gun drill, and then 1 meter gun drill, right? So if this machining is okay, then we can save this one as template. Okay, now let's save the drill that we built and save the template. I'm going to show you how to save the template for this drill sequence. Right, so I will say put a name like line O diameter 10 from L0. Actually, I should set a minimum L also, but in this case I start from 0 to 1000. Yeah, it's okay. For the actual, you should set the minimum also in order for this sequence apply. That's it. That's the name. Right. Then you click save here. Take a picture again. Zoom, unzoom. Take the picture and click OK. Then you can save. You can choose where to save. I'll choose back here, but now I add a new folder, my new template, and I'll set my new template here. Okay, so this will become our your company standard, for example. Let's cancel it. Okay, now we already have the template. So if you look into the folder here, you already have one file, ELT file. This is the drilling sequence for this type of hole. Yeah. So next step, I'm going to do the machining for the other side. Here, this side. So for this, we'll create another activate 56 first. Use this with procedures, and on assign group, because we have selected this surface from previous one, so we need to check on assign group drill. Let's go grouping, select all, and click auto group, right? After that, then we auto fit the sequence, and we'll set to the new folder and click OK. Right? If it don't apply automatically, it will ask you what to apply. For example, this whole, yeah, you can select manually if you want. Like this one. Oh, I'm going to use all same template. Yeah, and just OK. That's all. Right? So all the holes, because there's a true hole here, I don't have the template for true hole, so it will do only all the blind hole. And execute. So as you can see now, all the holes is done by the template. Right, so we have a standard drill, right, and we have the full depth drill. This is guide drill, full depth, and then full depth for the 100 mm, full depth for the 100 mm, and then chamfering, and then chamfering, and then chamfering, and then chamfering, and then the 400 mm gun drill, back, and the end. Okay, next I'm going to show you how to divide the procedure. Sometimes I don't know why a lot of people tends to post like one cutter, one G code, right? But for this stencil procedure here, within one procedure, there's a lot of tools here. So if you really want to divide the procedure into different cutters so that you can post out the G code one by one manually, of course you can do it automatic, yeah, with some special customization. Yeah. You can always like this, just select the procedure and go to NC Edit, and you should have, is it under NC Edit? Let me see. Yeah, you have a function called divide the procedure by cutter change, right? So you just click here, you automatic hide away the original procedure, right? Just in case you want to recalculate, then you delete all this and recalculate again, right? So this is the divider procedure. The first one is under drill, right? The second one is, let me hide all of it. Right, the first one is under drill, then the pilot drill, and then the 100 mm drill, and then the chamfering, and last is the gun drill. So for the gun drill, don't worry, the output is not a cycle, it's using a G01. Your assisting post can output a code, okay? But sometimes the machine side you might have some special M code need to be added. Yeah, we can do the modification for you, right? Don't worry. Next, I will post this gun drill procedure by using our three-axis free FOC pose, free pose. We call it DIY pose. This pose you can download from the link at my YouTube channel. Okay. What you need is to go find the video that explain what is the DIY DIY post. Yeah. DIY free post. There's a video there, so you get the link from there. You can download the free post, and I will show you the post. Go to post. Post program there. Post. Yes. Right. I'm going to use the DIY free post version 146. Right. It's a fun up post, and okay, let's display. And this is the G code. This is a G code, my friend. Right? So do you see here? There's a command here. Right? So you explain in each sections what you want, what the drill doing. I don't suggest you remove the comments, right? Yeah. Right? So just in case you want to add in something or delete the comment of the gun drill, or add some M code, special M code, okay? You can always you can always open this here, this PGF file, the PGF, with Notepad or with the Notepad++ that I've uploaded in my on the YouTube as well, right? Or you can use the Notepad. Just find the section with this one, gun drill sections. Just find the gun drill sections, and then you can edit, like, yeah, so you can change the commands if you want, or I can add, like, I don't know, for something, just add the M code, right? So you can do that, not a problem, right? So I just show you, like, add M code at the start. So just save. After save, you just go and repose the program. I'm going to repose the program after I change the PGF files. Right, and there's an M88 here. What is M88? I don't know. I just put it, yeah, to show you guys how to edit. That's it.
For both applications, use of conventional as well as single-purpose machines, drilling a deep hole requires precise knowledge of the machine design in order to determine the length of the drill. In the next few minutes, we want to show you what is important and what specifications must be made when ordering a gun drill. Deep holes can be drilled conventionally on a CNC machining center, MC for short. For a hole to be drilled precisely, a pilot hole is required. First, the surface of the workpiece should be machined perpendicularly to the hole center line. Then, a pilot hole has to be made for startup to a drilling depth of 3 times the hole diameter. This ensures that the gun drill is guided during startup. The actual drilling is carried out in up to 3 work steps. During the first step, the maximum drilling depth which can be reached is 40 times the hole diameter. Then a second, slightly smaller drill must be employed. With this, a hole 80 times the depth of the hole diameter can be drilled. A third drill, smaller once again, can extend the hole to a depth of 120 times the diameter. Gun drills with a brazed-on solid carbide head can handle a drilling depth of up to 40 times the hole diameter, whereas gun drills made of solid carbide can reach a depth of up to 80 times the diameter in one step. Cooling is done via interior channels in the drill, which are also used for chip removal. When drilling with a gun drilling machine, SPM for short, it's possible to reach the full drilling depth with one tool. A pilot hole is not necessary in this case. A drill bush ensures precise startup. It engages with the workpiece and guarantees precise guidance. Mobile steady rests enhance the stability of the drill. This procedure also involves using high-pressure interior cooling. Chip removal is integrated right into the drilling bush holder. An important point when drilling with gun drilling machines is that additional equipment is required. Steady rest bushes, a sealing disc, a drill bush, and an adjusting screw. To order a gun drill properly, it's important to observe the following. The drill length on the conventional CNC machining center is calculated on the basis of the following: the drilling depth, the regrinding length, the minimum distance, and the length of the driver. The length of a gun drill for a gun drilling machine is defined by the following parameters: the drilling depth, the regrinding length, the width of the drill bush holder, including the sealing case, the width of the steady rests, and the length of the driver. Matching drill bushes, sealing discs and steady rest bushes, and an adjusting screw must be taken into account when ordering or making inquiries. You will find forms for inquiries and orders in the back of the product catalogue. Correct orders of gun drills and accessories save time and costs.